welcome to our video on circular functions practice SAC solutions. The first table here is the table that you need to memorize. You can do that either using your triangles, or you can just straight memorize the table, or you could use the method where you count on your fingers. Up to you, but you need to have these values memorized. Okay, and here's the values filled in for you. You'll note this last value here, tan of pi over 2, is either infinity or undefined. Either of those answers is fine. Question 1. Using the exact values from the table above, state the exact value of the following. Sine 7 pi over 6. First step always is to draw it on the unit circle. 7 pi over 6 is going to be a little bit more than pi, so it's going to be here. Put your cast in, and we can see that in this quadrant sine is negative, so it's equal to negative sine of 7 pi over 6 take away pi. Which equals negative sine of 7 pi over 6 take 6 pi over 6, negative sine of pi over 6, which equals negative 1/2. Make sure you keep this negative going all the way through. Part B, tan of 5 pi over 6, negative tan of pi minus 5 pi over 6, which equals negative tan of pi over 6, which according to our table is negative 1 over root 3. Part C, cos, oh hang on, I forgot to draw my cast here. 5 pi over 6 is going to be in this quadrant. The sign is positive, tan is negative, and that's where I got this negative sign from. Apologies for not mentioning that at the start. Third one, draw your unit circle. 11 pi over 6 will be down here, where cos is positive, and we've got cos, so it'll stay positive. This one equals cos of 2 pi take away 11 pi over 6, which is equal to cos of pi over 6, which is equal to root 3 over 2. Final example, cos negative pi over 4. So if this is 0, negative's going down here, and it's in this quadrant here. Cos is positive, we're using cos, so we can keep it positive. So this is equal to cos of 0 take away negative pi over 4, which is equal to cos of pi over 4, which using our table is equal to 1 over square root of 2. Convert the following to radians in terms of pi. 20 degrees we need to times by pi over 180, which is equal to 20 pi over 180, which equals pi over 9. 210 times pi over 180 equals 210 pi over 180, which equals 7 pi over 6. Question 3, convert to degrees. 3 pi over 10, this time we times by 180 over pi, and we end up with 54 degrees. This one again, times 180 over pi, end up with 330 degrees. If theta equals pi over 6, find the value of 2 sine theta. So this is going to be equal to 2 sine of pi over 6, which equals sine of pi over 6 is a half, so 2 times a half, which equals 1. Sine squared theta is the same as sine theta all squared, which will equal sine pi over 6 all squared, which is a half squared equals a quarter. Sine of 2 theta. Sine of 2 times pi over 6, which is equal to sine of pi over 3. Using your table, it is root 3 over 2. Part D. Sine squared theta plus cos squared theta. Using our identity, we can look at that straight away and know that it equals 1, because sine squared theta plus cos squared theta, doesn't matter what theta is, as long as they're both the same, will always equal 1. Using identity. If you weren't sure about the identity, you could put in pi over 6 for both of these and it would end up equaling 1 when you finally simplified it fully. If cos theta is negative 4/5 and theta is between 90 and 180, find sine theta. So first thing I'm going to do is draw my unit circle. So theta is here in quadrant 2 between 90 and 180. I'm going to draw myself a little triangle as well from my unit circle. This is my theta, this is my opposite, this is my hypotenuse, this is my adjacent. If we know cos theta is negative 4/5, and we know using cast here that cos theta is negative in the second quadrant, 4 divided by 5, cos, using SOHCAHTOA, cos is adjacent over hypotenuse, so adjacent is going to be 4 and hypotenuse is going to be 5. Hopefully you look at this and remember that we can have a triangle, a 3, 4, 5 triangle. If it's a right angle triangle, the other side is 3. If you're not confident with that, you could use Pythagoras' theorem to solve and find out what this side is, and you would get 3. 3, 4, 5 triangles only work where 5 is the hypotenuse. So we've got all of these signs. We need to find sine of theta, which is opposite over hypotenuse, 3 over 5. Check if it's negative. Sine is positive here, so we keep it as a positive. So sine theta is 3/5. Tan theta is opposite over adjacent. Going back to our triangle, 3 over 4. And tan is negative in this quadrant, so we need to have negative 3/4. Question 6. State the period and amplitude of this graph. The period is equal to 2 pi over n, which in this example is 2 pi over 2. N is this number here in front of x, and the period is going to be pi. Amplitude, we can read straight off this equation. It's a number in front of the sign, so it's 3. Amplitude. Oh, you know what I mean. Part B, sketch the graph. We've already got the period and the amplitude, so we can use that information. It's a sine graph. I like to put a couple of dots in, so I know where I'm going. Amplitude of 2, so it's going to go up to 2 here. It's going to finish at pi again, come back to where it started. This amplitude is 2 as well, and then we can start to join these dots up. This should go through that dot there. Yours will when you draw it. Again, because you need to draw it from 0 to 2 pi, so we need to do one more cycle. Having a better go at it there. And yours needs to be a smooth curve. Do check when you're drawing a graph if they've labelled the axes and put the arrows on there. Really important to have your graph fully labelled. Looking at the red graph, state the amplitude and period. Amplitude is this amount here, so it goes from 0 up to 4. Period is how far one cycle, so it starts from here and goes to here. So 2 pi over 3 is one cycle. State the equation of the graph. Using our period formula again, period equals 2 pi over n. We know the period is 2 pi over 3. So n equals 3. And we've got the amplitude. And the other thing I noticed about this is it's a negative sign graph, because a positive sign graph would go like this. But we've flipped this one, so I need to have a negative in there. So we can start with negative 4 is the amplitude, sine 3 is the number in front of x, negative 4 sine 3x. You may have come up with a different equation for your graph. You may have translated it left or right. You could have used a cos graph that started from here and was translated pi over 6 across. Have a check, throw it in your calculator, have a check and see if you can find the solution. See if your graph fits the one that's here. Solve this for x is from 0 to 360. Really important to note that it goes from 0 to 360, so it's in degrees. It's not going to be in radians. Our reference angle, if we look up cos of a half, we should get our reference is 60 degrees. Draw our unit circle, and cos is positive here and here. So x equals 60 degrees, because this will be 60, and this one here will be 360 take away 60. Which equals 300 degrees. Final one, 2 sine x plus root 3 equals 0 from 0 to 2 pi, so we're using radians again. Two sine x equals negative root 3, moving the root 3 to the other side. Sine x equals negative root 3 over 2. Our reference, if we look up root 3 over 2 for sine, our reference is pi over 3. We have sine x is negative here and here. So we have x equals this one, pi plus pi over 3. And 2 pi minus, which is going to be 4 pi over 3 and 5 pi over 3 for our two solutions. Thanks for watching Part A Solutions.